Okay, so get this. Today we're looking into concrete that can heal itself.
Yeah, like it sounds crazy, right?
Seriously, buildings fixing their own cracks. It's like something out of a movie.
Yeah, it does. Kind of like a superpower.
So no tiny robots running around patching things up then?
Haha, no, not quite robots. But what we're talking about today is still pretty amazing.
Okay, I'm intrigued. So what are we talking about exactly? Magic?
Well, there are these two main methods, both super innovative. One uses, get this, bacteria, and the other uses these tiny little capsules filled with like a healing potion.
Wait, hold up. Bacteria in concrete. How does that even work?
I know, right? It's actually pretty ingenious. So they mix in these special bacteria when they're making the concrete.
Uh-huh.
But get this, the bacteria, they just kind of hang out dormant until there's a
Nothing
crack.
in?
Then water gets in, right? That's their cue, like a wake-up call.
Okay, water wake them up, and then they do what exactly? Build tiny little dams.
Not dams, but something even cooler. They start producing calcium carbonate.
Calcium carbonate, remind me what that is again?
Basically, it's limestone. You know, the stuff they make like statues and stuff from.
Oh, right.
So yeah, the bacteria produce this limestone and it basically seals up the crack.
From the inside.
Yeah, it's like they're microscopic little construction workers living in the concrete, always on call to patch things up.
That's wild. So it's basically constantly maintaining itself?
Exactly. They fix those tiny cracks before they can even become a real problem.
I bet people who are into biomimicry and stuff like that, this has got to be right up their alley.
Totally. It's taking inspiration from nature, using it to solve these complex engineering problems.
Speaking of cool solutions, you mentioned those capsules earlier, the ones with the healing potion?
Right, yeah. So imagine these tiny capsules, like little first aid kits, scattered all throughout the concrete.
I'm picturing them now. So what are they filled with?
This special sealant, it's like a really powerful healing agent.
So I'm guessing when there's a crack, it breaks open the capsule?
Bingo. The crack disrupts these capsules, they break open, and all that sealant spills out right out of the crack.
And then it hardens.
Yep. It hardens super fast, and boom, the crack's repaired.
It sounds like this capsule method would be better for bigger cracks than the bacteria,
It's
right?
sharp, that's right. The capsules can handle those bigger cracks, and they work a lot faster, too, like an emergency response team.
For people who love, like, futuristic tech and stuff, this has got to blow their mind.
Yeah, for sure. It's like straight out of some high-tech construction site in the future.
Both these methods, I mean, wow. They could totally change how we think about building things, couldn't they?
Absolutely. The potential here is huge. I mean, it is pretty mind-blowing when you think about the possibilities, right? But it's not just about how it works. You got to wonder, like, what does this mean for, for us regular folks?
Yeah, for sure. It's cool in theory, but what difference does it actually make?
Well, think about it. Buildings that could last like way longer, double or triple their lifespan, maybe even more. Bridges standing for like centuries, roads that don't need constant repairs, stuff like that.
Our cities would look totally different if buildings could last for centuries, huh?
Right, but it's not just about them lasting longer either.
What else?
It'd save a ton of money. Like all those repairs, they cost a fortune, right? And take forever. So less of that means everyone saves money, building owners, cities, even us taxpayers in the end.
So fewer construction projects, less disruption in our lives, and it's easier on the wallet. Sounds like a win all around.
Totally. Plus, think about the environmental impact. Less construction means we're using fewer resources, creating less waste. It's better for the planet in the long run. This stuff is like right in line with all that sustainability stuff everyone's talking about these days.
That's a really good point. It sounds like this could be a solution to a lot of problems we have now, so why aren't we using it everywhere already? What's the holdup?
Yeah, that's the million-dollar question. I mean, the potential is definitely there, but there are a few things holding it back. One of the biggest ones is the cost.
Yeah, money, figures.
Right. It's just more expensive to make this kind of concrete than the regular stuff. And a lot of developers, investors, they want to see a return on their investment quickly, so that higher upfront costs can be a deal breaker for them.
Yeah, I get that, but wouldn't you save more in the long run by not having to do as many repairs?
Oh, absolutely. But sometimes it's hard to convince people to think long term, especially when it comes to spending money.
Yeah, that's true. It's human nature, I guess. Is that the only reason it's not more popular, though?
Well, it's also pretty new still. Like, there have been some cool projects using it, and it works great in the lab, but scientists are still figuring out how to make it even better and cheaper to produce.
So it's just a matter of time before it catching on.
Pretty much. As it gets more efficient and less expensive, more people will start using it. That's my guess, anyway.
Makes sense. It's great to hear it's not impossible, just needs a bit more time. But before we get too excited about all the good stuff, what about the downsides? Are there any risks with this self-healing concrete?
That's a really important question. Like with anything new, we got to be careful, right? Make sure it's not going to cause more problems than it solves, especially when it comes to the environment.
Yeah, what about those bacteria, for example? Are they safe?
Well, that's what scientists are looking into right now. They're studying how those bacteria behave inside the concrete and whether they could have any, unexpected effects on the environment.
So far, so good, though.
As far as I know, yeah. They're also making sure the sealant used in those capsules is eco-friendly too. They don't want to be fixing cracks in buildings and polluting the planet at the same time, right?
Right, right. It's like, got to be responsible about this kind of innovation. Can't just price into it.
Exactly. But overall, I'm pretty optimistic. I think the benefits outweigh the risks. Like, imagine a world with more sustainable, longer-lasting buildings and infrastructure. It could make a real difference.
That's a pretty hopeful vision of the future. But even if this self-healing concrete does take off, there will always be a need for regular concrete, right?
For sure. It's not like this stuff is going to replace everything overnight. It's more about having options, choosing the right material for the right project. I know. Sometimes I don't need the fancy self-healings and stuff. It's all about making smart choices, thinking about the long-term benefits for everyone, both for us and for the planet. And speaking of smart choices,
It makes you wonder if concrete can heal itself. What else could we make self-healing? Like, what if our houses and our gadgets could fix themselves?
that's the really exciting part. It is just about concrete. Scientists are already working on all sorts of self-healing stuff, like polymers that can repair themselves.
Polymers, huh?
Yeah, they're used in tons of things like electronics, even medical implants. Imagine your phone screen could fix its own scratches. Or, get this, a heart stent that could adapt to changes in your body over time.
Okay, self-healing phone screens. I'm sold. No more cracked screens would be a dream come true. That's a huge deal.
I know, right? It sounds so simple, but think about it. And it's not just convenience either. In medicine, self-healing implants could be revolutionary. They could last longer, be safer, even help your body heal better.
Wow, so we're talking about like a whole new level of medicine here.
Exactly, like regenerative medicine and stuff. It's pretty amazing how quickly this stuff is moving from science fiction to reality.
It really is. Where do you think this is all going? Are we going to live in a world where everything can just fix itself?
I think we're definitely headed in that direction. The more we learn about self-healing, the more possibilities open up. It's not just fixing cracks anymore. It's about changing how we design and build everything in every industry.
It's pretty exciting stuff. Well, I think we've covered a lot of ground today. We've learned the science behind self-healing concrete, the good and the bad, and even what the future might hold.
It's been a great discussion. It really shows how innovation can make things better, both for people and the planet.
Absolutely. Who knew concrete could be so groundbreaking, right?
It's amazing what we can do when we put our minds to it.
For anyone listening who wants to know more about this, there's tons of information out there. Do some research, keep learning, you never know. Maybe you'll be the one to invent the next big self-healing thing.
The future is full of possibilities. It's up to us to make them happen.
Well said. And on that note, we'll wrap things up here. Until next time, keep exploring, keep those imaginations going, and we'll see you on the next deep dive.